Okay, in this video we're going to talk about similar figures, and we need to define similarity. Similarity is the same thing as being similar. So similar means the same shape but different size. Okay? And congruent means the same shape and same size. So that's the difference between similar and congruent. Similar is same shape, but it has different size, and congruent means the same shape and the same size. So congruent is just another word for congruent is equal. So I'm going to write that down right here. It's exactly equal. Similar just means that it looks like it, but it's a different size. Okay, so let's fill in the blanks. Two figures are similar if they have the same shape, but not the same what? Same size, right? We just talked about that. The corresponding angles are congruent, and the corresponding sides are proportional. So let's talk about what all that means. Okay, so here we have a triangle. We have a couple of triangles, triangle ABC and triangle DEF. And they tell us that this little symbol right there, that means that it's similar to. Okay, so that means that triangle ABC is similar to triangle DEF. And we can see that they're similar because they're both the same shape, they're both triangles, but more than that, they're both right triangles. And they're different sizes, so we know they're similar, not congruent. Okay, so now because we know that, then we know that the corresponding angles are equal. In other words, angle A, this angle right here, is the same thing as angle D. This word corresponding that we saw right here, corresponding, I want you to write this down, that means that they are in the same location. Corresponding means same location, same place, if you will. Okay, so what does that mean for my triangles? Well, what that means is that this A is in the same place as this D. So both of these angles are equal because that's what they tell us right here. The corresponding angles, again, corresponding is in the same location, and we're talking about the angles are congruent. Remember we said that congruent was the same shape and the same size. So, going back to the triangles, A and D are congruent. A and D are equal to each other. Okay, I don't know if you can see this little symbol right there, but that is an equal sign with a squiggly line on top of it. That means congruent. Okay, so that sign right there, that's the congruent symbol. And congruent means equal, right? So when we're talking about angles, we can say angle A is equal to angle B. We'll say they are congruent. So if angle A is equal or congruent to angle D, then angle B would be congruent to angle E up here because they are both in the same location. They are corresponding. And then angle C, we can see it's a right angle, so that's 90 degrees for sure. We know that. And that's in the same location as angle F. So we know that angle C and angle F are congruent. There's my congruent symbol right there. Now we're talking about the corresponding sides. And corresponding sides are not congruent. Corresponding sides are proportional. That means we can write a proportion. Okay? So here's the proportions right here. Corresponding sides, let's see if I can get my highlighters right quick. Okay, I'm going to need 3 different colors, and the first color I'm going to choose is going to be orange. This side right here, angle AB, that is the same location as this side right here, angle DE. Therefore, side, I don't know why I said angle, I meant side. Side AB is corresponding to DE. Because they are in the same location, they're corresponding. But also because they are corresponding, they're in the same location, they are proportional. So 5 and 10, we can write a proportion. Here's the ratio for those corresponding sides, 5 to 10. Okay, that's the ratio that I highlight, that's the sides that I highlighted in orange. Now I'm going to highlight the next sides in blue. So this right here, B to C, is corresponding, is in the same location as E to F. So now we know that this 4 right here is corresponding or is proportional to this 8 right there. So then the proportional we can write is, or the ratio we can write is 4 to 8. I think that these highlighters are making the numbers hard to read. So let me go over them real quick. But you have them in your paper so you know what they are. Okay, so now we have the last one. The last one is side A to C, and side D to F is in the same location. Okay, side A to C is 3 units long, and side DF is 6 units long. So we can write a ratio with those two, and that is going to be the ratio 3 to 6 right there. Okay, let me rewrite those numbers. Okay, now that we have all the ratios located and we know where those numbers came from, we can solve it. We can see if they are proportional or not by just looking at the ratios. Okay, if you cross multiply 5 times 4, 5 times 8 gives you 40, and 10 times 4 gives you 40. So we know these two ratios are equal, they are proportional. If you cross multiply these two, the blue and the green, it's going to be 4 times 6 is 24, and 8 times 3 is also 24. So when you cross multiply, you get the same answer, so you know they're proportional. Another way of thinking about this is with the reducing. If you reduce 5 tenths, you get 1/2. If you reduce 4 eighths, you get 1/2. If you reduce 3 sixths, you get 1/2. So that's the relationships between similar figures. Now, if you turn your page on the other side, you will see whether we need to determine whether or not these shapes are proportional. They are similar. And if the angles are equal and the sides are proportional, then we know they're similar. For example, 9. This 9 right here, side AB, that's proportional to, or corresponding to angle DE. Okay, so this side is corresponding to DE. This other side right here, CB, would be corresponding to FE. So we can write a proportion to see if they are proportional. If the proportion works, then we have a proportion. We have similar figures. So 9 and 18, they are corresponding, so I'm going to write my ratio. And then the other ratio was 7 and 14. So 7 and 14. Are these equal? Let's check. Okay, so I can reduce or I can cross multiply. I know some of you like to cross multiply, some of you like to reduce. In this one, in this instance right here, I'm going to go ahead and reduce, because I know both of these can be reduced and they all both going to give me 1/2. 9, if I divide 9 by 9, that's going to give me 1. And if I divide 18 by 9, that's going to give me 2. If I divide this one by 7, well, actually, I'm going to confuse some of you if I do that. So I'll go ahead and do this. I'll cross multiply for you. 9 times 14 and then 7 times 18. Does that give you the same answer? I don't know. Let's see if our handy dandy calculator can help us out with that information. And I'm not saying you can use a calculator for your homework, but for this point, let's see. 9 times 14 gives me 126. So this is 126. And 18 times 7 gives me 126 as well. So because they're both equal, they're both cross products, then I know these are proportional, so they are similar. Okay, here the question was not whether or not they're proportional. We're talking about shapes, and we know that the shapes will be similar because we can write a proportion with the sides. The sides are proportional. Okay, if you look at the other one over here, it's going to be the same thing. 8 is in the same location as 24, and this 15 is in the same location as this 40. So you can go ahead and write your proportion. 8 over 24, they are corresponding, and 15 over 40. To check to see if they are similar, cross multiply. and see if you get the answers. I'll let you do that one. Okay, sometimes we'll be asked to find missing sides. Like for example, these two triangles right here, they're similar, but we're missing this side right here. We don't know how long this side is. That's why we have an X right there. So we know this side is corresponding to this side right here, of this other little triangle. And that means that this side is going to be corresponding to this side down here. So let's go ahead and write our proportion and solve it. We have 4 over 12 and 2 over x. So if you cross multiply this proportion, or you can find your scale factor either way. Okay, but I'm going to go ahead and cross multiply. 4 times x, that's going to give me 4x. And 2 times 12, that's going to give me 24. So I have 4x equals 24. What I got to do now is got to divide by the number in front of that letter. That number is called your coefficient. Make sure you write that down. Coefficient. Okay, and the letter is called a variable, so we'll talk about that a little bit more. Right now, that coefficient, that's the number that we divide by every time, the coefficient. So we're going to divide by 4 on both sides, because 4 divided by 4 just cancels out. So that leaves me with just that one x right there, so I'll bring it down. But here I have 24 divided by 4, all that gives me 6. So now I know that x equals 6, and that's the missing side right here. That missing side has to be a 6. And that's my answer. Okay? Now if you look at the other one right here, we have a triangle, a rectangle, and we have corresponding sides as well. Notice that this side right here is the one that's missing. This is where my x is. But I don't know how long this side is right here. That's in the same location. But I do know that this side right here is 9, right? So if this side right here is 9, then because it's a rectangle, then this side over here has to be 9 as well. So now I know this side, and I don't know this side, is the one I'm looking for. And I do know this side up here on the top, and I also know this side here on the top. So I can write my proportion. 10 over 5 equals to the other proportion, which is going to be x over 9. They are in the same location. So now you can cross multiply. 10 times 9 is 90, and 5 times x is 5x. Now the coefficient is your 5. So we're going to divide by that coefficient, which is 5, and you divide both sides by the coefficient. 5 divided by 5 cancels out and leaves you with the x. And 90 divided by 5, well, that's going to be your answer. So you can finish that one, okay? If you look on the other side, you have 3 more application problems. Let's see, 1, 2, triangle shown below. Yeah, this one you have to find the, on this one right here, you have to find the x. So make sure that you write your proportion. These two sides are equal to or proportional. These two sides are proportional because they are corresponding. They're in the same location. And then on this one right here, they tell you these are similar. Which line segment is corresponding to AC? So they want to know which one is in the same location as AC. In this one you have to be careful because the triangles are a little bit flipped. Okay, so pay attention to the angles. Here you have a right angle, and here you have the right angle. So in this case, AC would be corresponding to the angle that's right on the right angle, and it goes to the angle that has only one little arc. And the angle that has one little arc is up here. So the angle, the side between the right angle and the one arc angle is going to be this side right here, EF. So these two sides are the corresponding sides. They are in the same location. So the answer to this one is going to be answer choice B. And now if you look at the last one, which of the following statements is true? Are all trapezoids similar? Are all isosceles triangles similar? Are all equilateral triangles similar? Or all rectangles similar? Draw a picture of each one and compare it. See what you think. And we'll talk about this tomorrow in class. Thank you.